China reportedly supplies Iran with hundreds of Manpads air defense missiles to counter U.S. air strikes. Iran is expected to receive an initial delivery under a contract of 300 to 400 Chinese-manufactured QW-12 and FN-16 man-portable air defense systems, according to a Reuters report on July 29, 2026. The acquisition seeks to address operational vulnerabilities in Tehran's static air defense network exposed during military engagements with the United States and Israel. By deploying highly mobile, infrared-guided shoulder-launched missiles, military planners intend to establish dispersed low-altitude defense coverage across strategic infrastructure, missile bases, and nuclear facilities. The reported defense procurement agreement is valued between $60 million and $70 million, establishing an average unit cost of $150,000 to $233,000 per launcher kit. Operating within engagement ranges up to 6 kilometers and altitude ceilings under 4 kilometers, the QW-12 and FN-16 systems utilize dual-band optical seekers to target low-flying aircraft, cruise missiles, and unmanned aerial vehicles without emitting detectable radar signatures. Reuters reported that Iran is expected to receive, within weeks, the first shipment under a contract for 300 to 400 Chinese-made QW-12 and FN-16 man-portable air defense systems Manpads, with a total deal valued at $60 million to $70 million. This represents an average expenditure of $150,000 to $233,000 for each launcher, but that figure may include missile rounds, optical sights, training equipment, spare parts, and transport containers. If Iran forms 4 launcher detachments, it could establish 75 to 100 firing positions. If it uses 6 launcher detachments, the same inventory could support 50 to 66 units, each assigned to a separate airfield, missile base, command facility, refinery, power station, ammunition depot, nuclear site, or logistics corridor. This would allow Iran to defend more individual locations than a comparable investment in radar-guided batteries, although each Manpad's position would cover only a radius of 5 to 6 kilometers and an altitude band below 4 kilometers. Iran also examined more advanced QW-18 and QW-19 launchers, but the choice of both the QW-12 and FN-16 indicates that immediate availability, price, and numerical mass took priority over acquiring China's most recent seeker technology. The unconfirmed purchase addresses a specific weakness exposed during the war with the U.S. and Israel. Iran's fixed air defense structure could be located, isolated, and attacked in sequence. Long-range systems such as the S-300 PMU-2 and medium-range batteries depend on radars, command posts, data links, electrical supply, and trained crews operating at known or repeatedly observed sites. Destroying the radar does not necessarily destroy every launcher, but it can prevent surviving launchers from receiving target information or coordinating engagements. A Manpads reduces that dependence. A 2- or 3-person team can move in a pickup truck, civilian van, or light tactical vehicle, conceal itself in a building, a hillside position, or an underground facility, and deploy only when warned. More importantly, the team can fire without emitting radar signals, then leave the position within minutes. This does not restore Iran's lost national air defense coverage, but it could create a dispersed threat beneath the surviving medium and long-range layers. The operational purpose of this reported purchase is likely to make low-altitude penetration more costly for the U.S. by placing launchers where terrain, infrastructure, and predictable aircraft routes compress the attacker's maneuver options. The FN-16 is the more capable missile in the reported package and was introduced publicly at the 2008 Zhuhai Air Show as the successor to the FN-6. The missile measures no more than 1.6 m, has a diameter of 72 millimeters, and weighs no more than 11.5 kilograms, while the complete firing set weighs up to 18 kilograms. Its engagement range extends from 500 m to 5.5 or 6 kilometers, with a minimum altitude of 10 m and an upper engagement limit of 3,800 to 4,000 m. Missile speed exceeds 600 milliseconds, equal to more than 2,160 km/h, and the FN-16 can sustain maneuver loads of at least 18 g in frontal, side, or rear attacks. Reaction time is approximately 5 seconds, enabling rapid engagement following target acquisition, particularly against helicopters, cruise missiles, and drones emerging from terrain masking. The FN-16S seeker combines infrared and ultraviolet channels in a quasi-imaging architecture, while laser proximity and impact fuses allow detonation near the target or on direct contact. The claimed single-shot probability reaches 0.8 against aircraft and 0.7 against cruise missiles, as the guidance system is designed to improve discrimination between the target's thermal signature and flares or other infrared decoys. The QW-12, for its part, has a less advanced countermeasure capability. Developed by China Aerospace Science and Industry Corporation (CASIC) and introduced in 2014, the QW-12 employs a passive infrared homing seeker consistent with earlier Q-series missiles, enabling fear-and-forget engagement without radar emissions and reducing susceptibility to electronic detection. The QW-12 missile is 1.645 m long, measures 71 to 72 millimeters in diameter, and has a complete combat weight of 18 kilograms. Its engagement range is estimated at 500 m to 6 kilometers, its altitude envelope at 10 m to 4,000 m, and its speed at close to 600 milliseconds, or Mach 1.8 under standard atmospheric conditions. These values place it in the same general performance class as the Russian 9K-338 Iglos, but below more advanced QW-18 and QW-19 missiles due to its seeker processing and reduced infrared countermeasure resistance. The QW-12 is therefore more credible against helicopters, transport aircraft, cruise missiles, turbojet-powered drones, and older combat aircraft than against modern fighters carrying integrated missile warning sensors, automatic flare dispensers, and directional infrared countermeasures. Against a fighter, the most favorable firing solution would come from short range, from the side or rear quarter, and before the aircraft begins an automated defensive sequence. Against a low-flying drone or cruise missile, the main constraint would be early detection rather than missile speed. If confirmed, the combined QW-12 and FN-16 inventory would be most useful in predictable low-altitude corridors rather than in uniform territorial defense. For instance, Iran could position teams along the Zagros valleys, around airfield approaches, beside missile storage complexes, near refinery and petrochemical zones, at bridges and tunnels, and along routes likely to be used by U.S. helicopters or terrain-following cruise missiles. A cruise missile flying at 240 to 270 milliseconds would remain inside the theoretical 6 kilometers envelope for 22 to 25 seconds if it crossed close to the launcher. In practice, visual acquisition, target recognition, and seeker lock could reduce the firing opportunity to fewer than 10 seconds. Larger unmanned aircraft powered by piston engines or small turbojets would offer stronger infrared signatures, while small electric drones may remain difficult to lock unless they're close, silhouetted against a cold background or carrying a hot payload. High-altitude strike aircraft would normally remain outside the engagement range, and aircraft launching weapons from 50 kilometers, 100 kilometers or farther would face no direct threat from those Chinese manpads. The main effect would be indirect. U.S. and Israeli aircraft would need to remain higher, avoid certain valleys and approach corridors, release weapons from greater distance, carry more countermeasures, and devote more surveillance assets to finding small mobile teams. For the delivery, Reuters identified a Urumqi-Pakistan-Iran route, which could support concealment, but also reveals the scale of the logistical problem. Urumqi is Xinjiang's principal rail, road, and air hub and offers access to routes leading toward Pakistan and Central Asia. Movement through Pakistan would avoid a direct maritime route through the Gulf of Oman and Strait of Hormuz, where vessel movements, port calls, and unloading activity are comparatively easy to monitor, but it would remain vulnerable to satellite observation, aviation tracking, customs records, and ground surveillance. The potential contractual intermediary, Zhongqing Baoshang International Investment, is a registered company from Hong Kong, a city that has repeatedly appeared in Iranian procurement networks. Its trading companies can broker contracts, arrange financing, shipping, and export documentation while creating greater separation between the end user and the original Chinese supplier. Therefore, since 2023, The United States has sanctioned numerous Chinese and Hong Kong-based firms accused of supplying Iran with dual-use electronics, carbon fiber, machine tools, missile production equipment, drone components, and financial services. The reported Manpads contract fits a broader pattern of indirect Chinese support to preserve the Iranian regime while reducing the diplomatic and sanctions risks. Iran's Nahid-2 communication satellite, for instance, entered orbit in July 2025 aboard a Long March 6A launched from the Taiyuan Satellite Launch Center. Iran also uses China's Beidou system for positioning, navigation, and timing, providing an alternative source of guidance and synchronization for missiles, drones, and military communications. The IRGC Aerospace Force separately acquired the Chinese-built TE-01B satellite for $36.6 million, then used it to observe U.S. installations in the Gulf before and after attacks. Its resolution, 10 times better than NOR-3 and 20 to 30 times better than NOR-2, allows the identification of aircraft types, support vehicles, individual structures, and strike damage. China also purchases more than 85 to 90 of Iran's exported crude oil, with volumes frequently above 1.3 to 1.5 million barrels per day, while the March 2021 China-Iran Comprehensive Strategic Partnership covers energy, infrastructure, finance, telecommunications, aerospace, and defense cooperation. Supplying or facilitating several hundred Manpads serves a narrow strategic purpose for Beijing. It helps Iran preserve its missile bases, command sites, and energy infrastructure, complicates U.S. and Israeli operations, and protects a major partner of China's westward strategy without creating a formal alliance, committing Chinese forces, or providing Iran with highly visible assets, such as fighter jets. That would seriously complicate a political deniability towards the U.S.